Good afternoon. This is Andrew Geens speaking. Welcome to our webinar on ISO 50006. This is a bit of a unique experience this afternoon. Not unique because you're the only person listening, but unique because it's my first webinar. Don't worry, I'll talk to you all as if you are the only person listening. Apparently we could have recorded this and broadcast it later, but no, we like a challenge and we're doing it live. So here goes. During the presentation, if you have any questions, please submit them through the dashboard. At the end of the presentation, I'll make my way through the submitted questions. If I'm unable to answer all of the questions in the time available, there will be an opportunity to submit any unanswered questions through the follow-up survey that will be emailed out tomorrow. So this presentation is intended to be an introduction to the standard. We won't be going into a lot of detail with the time available, but hopefully the webinar will enthuse you about the standard and encourage you to have a look at it yourselves in due course. It was originally prepared and delivered to a small team of 50,001 auditors, but I think it's going to be useful for anyone involved with energy management, whether it's to do with 50,001 or not. I quite like the standard. There are lots of help boxes in the standard, which is slightly unusual. There's normally informative annexes, but not normally a lot of help boxes. So if we just go into the first slide, for those of you that like to count, there are 30. This is just a bit of signposting to give us an overview of what we're going to be looking at. So obtaining relevant energy performance information from the energy review as a starting point, identifying energy performance indicators, establishing energy baselines, using energy performance indicators and energy baselines, and maintaining and adjusting energy performance indicators and energy baselines. The standard starts with a few definitions, so we'll just quickly have a look at those. Start with adjustment, the process of modifying the energy baseline in order to enable energy performance comparison. It's worth noting here that although the baseline may imply or infer something that's fixed in time, it is not fixed forever. If things change with the organisation, it's quite usual to then review your baselines and adjust if necessary. So we'll talk about that later on. Baseline period, a defined period of time used to compare energy performance with the reporting period. This is usually a year, but it can be something else. Again, we'll look at that later. Energy baseline is a quantitative reference providing a basis for comparison of energy performance. Notice there is an S in brackets there, so it could be plural. And with a well-developed management system, you'd probably expect it to be plural. If you have more than one energy performance indicator, you'd expect it to be more than one energy baseline. Okay, energy performance, measurable results related to energy efficiency, energy use, and energy consumption. So these would probably be derived from the energy policy that would already be in place, objectives and targets, etc. Energy use, manner or kind of application of energy. This can be a useful pointer for determining significant energy uses later on. Just a few more definitions. Relevant variable, quantifiable factor that impacts energy performance and routinely changes. So this would be used to normalize. I think if we're looking for examples as we go through the slides, I'm probably going to use weather because that's a fairly straightforward and easy to understand, relevant variable, and although it won't always be applicable, I think it's a good one to use as an example. Significant energy use. Energy use accounting for substantial energy consumption and or offering considerable potential for energy performance improvement. So this could be a significant piece of equipment or an energy center, or it could be a production line. Static factor, that's an identified factor that impacts energy performance and does not routinely change. The standard does give some examples of this, and in addition to that, we could add things like floor area. The standard gives examples such as the number of weekly production shifts or the number or type of occupants. But I'll probably use floor area to illustrate some points later on. Okay, that's the definitions out of the way. And go into an overview. I think whatever we're talking about managing, this is a generally applicable phrase. I'm sure you've seen it before. You can't manage what you can't measure, and it's certainly true with energy management. So what are we planning to measure? What are we going to measure? Energy consumption is an obvious starting point. Energy use, so key types of energy use, cooling or compressed air. For example, you might want to be measuring how much energy is being used for compressed air and have that as an objective to reduce it. Or energy efficiency. You might be aiming to improve the efficiency of a process over time. All of these are potential energy performance indicators, but that's not an exclusive list. Energy performance indicators can be applied at facility level, system level, process, or equipment levels. It would be usual, I think, with a young system just at the setting up stage to be starting at faculty level. The metering available might limit you to doing that initially, but the aim would be over time to improve sub-metering so that you can develop performance indicators for individual systems, individual processes, down to significant bits of equipment eventually. The other thing to think about with energy performance indicators is who's going to be using them. So you can develop different performance indicators for different audiences. So if you're presenting to people who are not particularly technical, maybe a finance director who's more interested in money. With energy, it's quite straightforward. A unit of energy has a cost associated with it, so you can have parallel indicators, 1 kilowatt hours and 1 cost, depending on who's looking at it. But whatever your performance indicators are, they should all have a baseline and a target. The standard talks about achieving continual improvement, and it's probably worth mentioning on this slide, it may come up in questions later, that in achieving continual improvement, not all energy performance indicators will show improvement in the same period. This is more of a problem if you only have one performance indicator, but when you have many, the principle of continual improvement is such that you wouldn't expect all of them to be improving at the same time. So this is quite an important slide. I think it's one of the few illustrations I've taken from the standard. This is showing us the concept of the baseline period and the reporting period for an energy performance indicator. So you can see the graphs at the bottom of the screen showing a lump of energy being used in the baseline period, and then conveniently a smaller lump of energy being used in the reporting period, so showing a reduction. But the bar chart above it shows us the energy performance indicator being used as the baseline figure, a representative value, and target value. So this illustrates very concisely that the terms baseline, energy performance indicator, and target are all referring to the same thing. You need to be working the same units to compare them. So, for example, kilowatt hours per square meter might be the metric you're using. So your baseline will be expressed in kilowatt hours per square meter, as will your EnPI for the reporting period and the target. The important thing is it's with regard to a reference period of time. So using the typical period of a year, you'll be talking about kilowatt hours per square meter per annum for all three things. I think in my experience there has been a bit of confusion over the use of the term baseline, and people often present baseline information in the form of the graphs you see at the bottom of the screen, but it does need to be converted into the same metric, the same performance indicator, such as kilowatt hours per square meter for comparison. It's basically the energy performance indicator in the first period of monitoring. Okay, moving on to obtaining relevant information and defining energy performance indicator boundaries. Usually the three boundaries would be defined as individual, system, and organizational. There's supplementary information on this in Appendix B. And once you've established your boundaries, you're then looking at defining and quantifying energy flows. And the fence diagram will be helpful in identifying energy flow across boundaries, showing energy flows with and across boundaries. These are the flows that need to be measured, and availability of appropriate metering and measurement is an important consideration in selecting energy performance indicators. Wasn't listed or isn't listed in the standard as an example energy performance indicator, but the importance of appropriate metering to formulate your energy performance indicators does mean that there's a good case for making the availability of metering an energy performance indicator in the early life of a system. In other words, to what degree, what percentage of your energy use can be identified through submetering. And at the starting point, that might be 0. So there would be continual improvement demonstrated by increasing the proportion of energy that is submetered. I don't think that would survive long into the life of a system, but it would certainly be valid in the early years. The standard gives an illustration of a fence diagram just to help you understand what they're talking about. So you can see here a site with 3 buildings, and the energy flows in and where there is metering. So you can work out where the energy is going and what's using it. So in this example, if we wanted an energy performance indicator to monitor the chiller performance, the chiller would need to be metered. It's not not metered in this illustration. So moving on to defining and quantifying relevant variables, it is important to identify and exclude variables that have little or no influence, and there's a practical help box in the standard to assist with this process. These are the help boxes I referred to earlier. So here's an example from one of these help boxes to encourage you to go and have a look at the standard yourselves. This is using the weather example that I said I'd probably keep coming back to. This graph is showing that by monitoring your energy use for cooling and for heating over the 12 months of the year, we can see that the cooling energy is higher outside of the winter months, in the warmer months, and it drops off in the winter, and the reverse is true for the heating. The energy use goes up in the winter when it's colder. So it's clear that the cooling and heating energy is a relevant variable from looking at a simple visual representation like this. But you shouldn't make assumptions. You should always do this sort of testing and illustrating, because it might seem obvious to some of you that you're going to use more heating fuel in the winter, for example, so that it is a relevant variable. But there would be circumstances when weather would not be a relevant variable. Would anyone like to suggest examples? Oh no, you can't do that, can you? Okay, I'll have to give you some answers. A very well insulated building with high casual gains would probably be self-heating, and you wouldn't see that change in energy use as the season changed. You might see changes in cooling in that sort of building. In a building with no glazing and with a lot of process heat gains, it might be the process heat gains that are driving the cooling load rather than the weather. So sometimes including weather as a relevant variable is going to be misleading, and it isn't going to be having an influence on the information that you're monitoring. Another illustration from the help box in the standard, just showing you graphically the idea of checking, once you've decided something's a relevant variable, is it significant? Because there's not a lot of point doing the work to make the necessary adjustments for relevant variables if they're actually not very significant. So in a building where the weather is a relevant variable, if you plot something like degree days, which are an indicator of how much heating you might need, against your heating energy use, if you saw a nice closely aligned set of results, as in A, that's telling you that the weather data is significant. If you go to C and they're scattered all over the place, that's suggesting that there are other things that are influencing the heating load, and it's not significantly being influenced by the degree day information. So there's some very simple graphical techniques you can use to help you deciding what variables you do need to worry about, and in fact whether they are relevant variables at all. So the opposite of a relevant variable is going to be a static factor. So we'll have a quick look at that. It is important to separate out static factors from variable factors. In a building, the number of occupants may be a variable influencing energy use, or it might be quite static. In a theatre, for example, they may be variable, but in an office, static. Another example that occurs is having recently been at an event with an exhibition. If you're in an exhibition hall, depending on who's booked an exhibition, you may use half of the hall or 3/4 of it or all of it. And if you're at an exhibition and you look behind the stands, behind the pretty fronts, you'll find just an empty hall on the other side. So the floor area that would normally be static in that sort of situation is going to change day by day depending on who's booked exhibition space. But you still need to check whether that was significant or not. It might be that even though only half the exhibition hall is in use, the rest of it is still being heated, and maybe if it's not being controlled very well, still lit, and it's actually not, whether it's full or half full, it's not affecting the energy use. So moving on to gathering the data. This is reinforcing the you can't manage what you can't measure principle. The organisation needs to specify the data needed for each energy performance indicator along with relevant variables and static factors, and then try to measure what is important. Don't fall into the trap of making important what you can measure. If your submeters are not actually measuring anything that's very important, having done that analysis, don't use them for the sake of it. If the things you've decided are important don't have metering, that's where they need to go. Again, there is a practical help box in the standard to assist with this process. So still on measurement, energy should be measured using permanent meters or submeters. There are temporary meters that can be used. It shouldn't really be used permanently, but they're very useful for fact finding. You know, if you're not sure where significant energy uses are, you could install temporary meters to gather that information, but you should be doing that as a step towards putting permanent metering in where you find it's appropriate. Energy performance indicators and metering capability, sub-metering capability specifically, are a bit chicken and egg. Energy performance indicators should only be developed where you've got appropriate metering, and metering capability should be developed to meet the requirements of appropriate energy performance indicators. It is for the organisation to identify appropriate energy performance indicators. It's your business and you're trying to manage your energy. So if any of you are interested in today's talk because you are aiming for third-party verification, you're looking for energy management system verification, that third party should not be telling you what your energy performance indicator should be. It is for you to decide. You might find that they will question whether you've picked the best ones, but they shouldn't be telling you what they should be. Also on measurement, we need to think about selecting data collection frequency. The data period can be longer than the baseline or reporting period, but must have a frequency, an interval, and this is the important thing, so hourly, daily or weekly, that facilitates analysis. Frequency must be right to capture changes in operating conditions. If you are monitoring, sticking with the same examples as before, if you're monitoring heating in a building, taking a reading once a day of the energy used to heat the building wouldn't show up the fact that the heating was on when the building was empty. You'd need to be monitoring hourly to do that. So that's an example of why you need to be careful with your frequency selection. So on to ensuring data quality. Energy performance analysis should always start with a sense check of the data. It is tempting when you've had information collected automatically and put into spreadsheets. It all looks very very tidy and neat and ready to use. You do need to check that the data you're using is reliable. Faulty metering, faulty data capture, unusual operating conditions may produce significant outliers which would need to be checked. You know, they may be real, but they may be false. There are a number of things you can do. There's a practical help box again to help you with this process, but it might be worth, if you've got similar processes, for example, that would normally be using similar amounts of energy, to compare those side by side and see if there's any anomalies, or just plot energy data over time and just look for unusual blips in the data, things that look like there might be something wrong. The important thing is not to just dash in to use the data without doing a bit of sense checking. So let's move on to identifying energy performance indicators. When identifying performance indicators, an organisation needs to have a good understanding of the fixed and variable loads for the business. This is why it's important that you decide your performance indicators. What you need to remember is they should, when compared over time, allow the organisation to establish whether there have been changes and whether targets have been met. So this is how you're able to demonstrate that actions you've been taking are showing benefits. The standard talks about four main types of energy performance indicator: measured energy values, ratio of measured values, statistical models, or engineering-based models. Most typically you'll be using the first two, but you may develop into the others later, depending on the complexity of your processes. So I mentioned earlier that you do need to think about who's going to be using these performance indicators. They do need to be understood by their users, so multiple EnPIs may be required. There's no harm at all in effectively duplicating by changing, for example, from energy units to money units, if that helps people understand what they're looking at. And again, you'll get fed up of me saying this, there is a practical help box in the standard to assist with this process. I don't mind repeating this often because, as I said in the introduction, I think this is a particular strength with this standard. So, determining the specific energy performance characteristics to be quantified, the organisation needs to choose EnPIs that will meet their user needs and the complexity of the application. Table 2 in the standard shows the types and applications of energy performance indicators and provides a lot of helpful examples for the four different EnPIs. I was tempted in planning this presentation to include a few examples, but this is quite a lengthy table, and I did say in the introduction the idea was to tempt you to go and have a look at the standard yourselves, so I think I'll leave that one as a tempter for you as well. I think if we start going into the detail of the table, we'll use up the remaining time. How's that for a tease? Okay, let's go on to establishing energy baselines. The energy baseline is characterized by the EnPI during the baseline period, which is the standard way of saying the energy baseline is the energy performance indicator during the baseline period. As I said earlier when we had the graphic up, I think this is something that passes some people by. The use of the term baseline I think is used because it's sort of universally understood when translated into other languages, but I think it does for a lot of people, conjure up the image of a line on a graph, and it's not. It is the energy performance indicator that you're using. So the comparison between the baseline and the reporting period energy performance indicator is used to illustrate progress or changes with reference to the baseline period. And it's established using the following steps: determining the specific purpose, determining the suitable data period, data collection, and determine and test the baseline. So let's look at those points in a bit more detail. Determining the baseline period. The baseline and reporting periods should be long enough to ensure that the variability in operating patterns are accounted for by the EnB and the EnPI, and typically these periods are 12 months to account for seasonality. You could do it more frequently than that if you have established that seasonality isn't a variable, isn't a relevant variable. But it's a good idea to use 12 months if there's no good reason not to, because it fits in with reporting cycles and other management system items. There is a practical help box in the standard to help you with this process again. No one noticed we missed a slide there. Moving on to determining and testing energy baselines. To determine the energy baseline, the corresponding performance indicator should be measured or calculated using the energy consumption and relevant variable data from the baseline period. If appropriate, the baseline should be tested for validity to ensure that it is an appropriate reference for comparison. Here the standard is talking about statistical testing, which would be the subject of another webinar. Okay, we're moving into using the performance indicators and baselines. So a lot of information in setting it up and moving on to using them. So you need to have determined when normalization is needed. Direct comparison of energy consumption between a baseline period and reporting period, or even from year to year, which you might be doing as well, can only be accomplished if there are no significant changes to the relevant variables. Otherwise, normalization is required. Annex D provides a lot of useful and detailed information on normalizing, and there are lots of other publications. The Energy Efficiency Office used to publish a series. I don't know if any of you can still access those. They're out of print now, and the technology advice in them and the case studies are all very dated, but the basic normalized performance indicator information is still a very good starter for someone who's new to this. Just to put it in very straightforward terms, if we were talking about heating energy consumption, to stick with the same example, and you've actually identified some improvement opportunities and you've implemented those plans, and you did that in 2016, so you were monitoring in 2017 to see how effective it's been, and then 2017 turned out to be an unusually cold winter. Well, in an exceptionally cold winter, you'd expect to use more heating fuel, and that would make it difficult. That would mask any benefits from your improvement plans. You might end up deciding that your improvements have been a failure, quite unjustifiably, if you haven't made adjustments for the weather. So normalizing is very important when you're making those comparisons for different periods of time. Yes, okay, moving on to calculating energy performance improvements. To assess changes in energy performance, organisations should quantify energy performance indicators during the reporting period and compare these values to the corresponding baselines. There is a practical help box in the standard to help you with this process. Just to illustrate how helpful, possibly too helpful, there's an example in help box 8 that tells you that if your energy use in the baseline period was A and your energy use in the reference period or recording period was B, the improvement is A minus B. It is very easy to follow the advice. So, communicating changes in energy performance. Energy performance should be presented based on the needs of the users if it's going to have any impact. It should typically be shown or reported with the EnPIs, EnB, and an energy target value. Annex E provides information on doing this. But if you remember the illustration we looked at very early on in the presentation, that was explaining baselines and performance indicators and targets. It is actually a very good way of reporting. Just to remind you, the bar chart at the top of the slide is a very good way of addressing the bullet point there. It should typically be shown or reported with the EnPIs, EnB, and energy target value. So if I was conducting a 50,001 audit, I'd find it quite useful to see the information presented in that way. Okay, I should be prefixing this with, and finally, following changes to facilities, systems, or processes, organisations might need to think about adjusting energy performance indicators and energy baselines. They should review their current baselines and performance indicators to ensure that the changes haven't rendered them no longer appropriate. There are several tests for determining this, and the standard, as you'd expect by now, provides examples in a practical help box. So you could have changed the fuel you're using. In manufacturing, you might have changed materials. You might have gone from manufacturing something with aluminium frames and replaced it with plastic frames. Could have an impact, and you need to reset your baselines and start again from that point. Or it could be a complete change of use of the building, which would justify resetting and starting again. As I said very early on in the presentation, baselines are not fixed forever. If things change, you do need to have a process for reviewing that and effectively resetting the baselines and starting again. Okay, that I think this is the last slide. It just remains for me to thank you for listening. I hope you have been asking questions as I've been going through those slides. I'm just going to take a minute now to have a look and see what questions have come in. Yeah, we've got a couple of questions saying, is the standard based on or aligned with IPM VP? It's not specifically based on, but it is consistent with, I think, is the answer to that question. Where should the energy meter sub-meter be installed? Within an apartment or the communal cupboard in the corridor? I think that's a very project-specific question. I think it would depend a lot on what you're actually metering. So I think I'd better ask the person who asked that question to submit it again with a bit more information. With the time available, I'm trying to pick up if there's common questions. will the slides be recorded and available for attendees? Yes, you'll be notified tomorrow how to pick up a record of the webinar. A couple of people asking variations on that. I've been asked by someone, is the demand for 50,001 rising with ESOS phase 2 coming? In terms of our own business, we are talking to a lot of people who are considering this for ESOS phase 2. In terms of overall statistics, the International Standard Organization do publish statistics about 9 months in arrears for the previous year, and the number of 50,001 certificates being issued has not quite, but roughly doubled 2 years running. And the biggest use of 50,001 is in Europe, and all European member states are doing something like ESOS. It was driven by a European directive. So I guess there's an implication there that ESOS is impacting uptake, but I think there are a lot of people that use it on its own merits as well. Yes, a lot of the questions are about 50,001. I should just reiterate that the standard I've been talking about throughout the presentation is 50,006. Of course, it is very useful to anyone who's operating a 50,001 compliant system or aiming to. But as I hope I stressed in the introduction, it's equally useful for people that are simply trying to manage their energy better. Yeah, another question. I've talked about 12 months of data being important if seasonal. Are there methods to mitigate this if only, say, 3 or 6 months worth of data is available? There are statistical methods you could use. You could use historical weather data to infer what it might typically have been this year. But it's not going to be as good as having the actual data, because as we've already established, weather is often a relevant and significant variable. So whilst you could use statistical methods to fill in missing data, it would be typical and therefore less accurate data than having the actual data. But it would be better than doing nothing, certainly. Someone's asking whether you can access a copy of the standard. It's published by BSI, so you'd need to go to the BSI bookshop. I'm not sure whether this particular standard is available through any of the industry information indexes. I'm sure lots of standards are, but I don't know whether this one specifically is. But if you wanted your own copy, you'd need to go to BSI. Someone's asking what are the expected changes in the 2018 version of the 50,001 standard, which is slightly off topic, but I guess a lot of you are tuned in because you're interested in 50,001, judging by some of the other questions. The 2018 version isn't quite finalised. The deadline has passed for feedback from the consultation earlier this year that's been conducted for the UK. The main driver behind the new version is sort of moving to harmonisation with other standards in the interest of people wanting to develop integrated management systems. So it's becoming much more aligned with 14,001 and 9,001, for example, as will the recently draft released 45,001 health and safety management. So other than that, probably couldn't be more specific because we're not at a final version of the new 50001 standard, but that's certainly the driver behind it. It does mean that the phrase continual improvement is used a lot more than it has been in the past. Yeah, someone saying they've seen on a forum which indicated that ISO 50001 would not meet ESOS requirements for round 2 of ESOS. I'm not sure what that's based on at all. I've certainly not been made aware of anything like that. The limitations of ISO 50001 for meeting ESOS requirements are where it doesn't cover all energy used by an organisation. But other than that, it is expected to be suitable for the requirements for phase 2. Okay, someone's, again, quite a detailed question. Does 50001 indicate some methods on correcting anomalous baseline data depending on the variable, e.g. if the anomalous weather conditions occurred during the baseline data period rather than the reporting? That is an interesting question. I'm not sure there's an easy answer. There's lots of advice. Well, the short answer is I don't think 50001 itself indicates methods for correcting anomalous data, but there is lots of advice out there. There is some in 50006, as we've been explaining today, and there would be other statistical techniques that could be used. So if the baseline year is the very unusual year, I think is the thrust behind that question. But of course, the normalizing procedure would take account of that, because you'd be comparing the degree day data for the baseline year with the degree day data for the reporting year, and that would deal with that if it was a simple degree day data type of situation. Someone is asking a question, another 50001 ESOS linked question. If the new version of 50001 calls for continuous improvement, I'll correct the question there. Actually, it calls for continual improvement, not continuous. They're not the same. And I'm not suggesting we go into an English language lesson at this point. Continuous improvement, very briefly, means all the time improving, every minute of every day. Continual improvement means over time improving, with periods of measurable improvement and periods of consolidation. So continual and continuous are not the same. But the question is about whether it's considered an alternative route to ESOS compliance, and will ESOS Phase 2 also call for continual improvement over Phase 1 submission? No, it won't, because ESOS reporting and ISO 50001 are not interchangeable. The use of ISO 50001 is, I'll choose my words carefully now, is a better process than simply complying with ESOS. ESOS is a baseline, if you like, to borrow a phrase. It's asking you to report once every 4 years. It's asking you to identify energy saving opportunities, but it's not asking you to act on them, and it's not asking you to demonstrate continual improvement. The reason 50001 is accepted as an alternative to ESOS reporting is because it does all that and more. So that's the basis of me saying it's a better way of doing it, because you are being asked to demonstrate continual improvement. And if you're interested in managing your energy costs, you're presumably interested in keeping on top of it and not having a look once every 4 years. Yeah, I've got a question that says, are weighted indexes, e.g. combining different EnPIs, acceptable? Short answer is yes. You'd need to be able to explain why and what you've done, but yes. Another one here is saying, oh, I think it's an extension of the original question, e.g. kilowatt hours per square metre for offices, but kilowatt hours per car park space for retail parks. Yeah, you're basically talking about having a hierarchy of energy performance indicators, and the amalgamated one would be the equivalent to the one that you started with before you were able to identify all your different processes. So you can certainly do that, because for certain users that bigger picture might be more useful and understandable, but you'd still have the detailed EnPIs underneath for people who would find those useful. Someone saying, did I say standards at XPSI? I said, no, I didn't say that. I said that you can buy the standards through the BSI bookshop. Okay. Someone has asked if EnPIs with developed multiple variables, driving factors, and combined in a multivariable regression model. Again, the answer is yes. Have a look at 50006. There is advice on doing that in 50006. This may not be helpful to anyone else listening, but somebody has asked a question that might be a good one to finish on, because I'm mindful of the time and some of you probably need to get back to work. Someone has asked if I had a hand in writing the standard and the help boxes, perhaps from some of the comments I made. No, I didn't have a hand in writing the standard. I've just found it very useful in clearing up some perceived misunderstandings. As I said in the introduction, we've used it for training our own auditors and thought it would be useful to share with others. So thanks again to everyone for listening. If I haven't answered everyone's questions, as we said earlier, there is a vehicle for you to keep the questions coming in, and we'll try to get to all of them in a timely manner. Thanks all for listening.